Picture a campfire somewhere in southwestern France. The date is roughly 17,000 years ago. The people gathered around it are anatomically identical to you. Same brain, same hands, same capacity for language and planning, and the particular human tendency to argue about things that don't immediately matter. They are wearing animal skins. They are cooking something over the fire, and what they are cooking is something that no human being alive today has ever tasted or ever will taste, because the animal they are eating no longer exists. It was hunted to the edge of a cliff, metaphorically and sometimes literally, by people exactly like the ones around that fire, across thousands of years of pressure that the animal had no evolutionary framework to handle. It had survived ice ages. It had survived climate shifts that reshaped continents. It had survived everything the Pleistocene threw at it for hundreds of thousands of years. It did not survive us. And this is not a story about one animal or one culture or one bad century of hunting. This is a story about the systematic, continent by continent, species by species transformation of the world's megafauna by a single predator. A predator that was small, slow, weak by the standards of the animals it was killing, and that nonetheless managed to eat its way through the most impressive roster of large animals this planet has produced in tens of millions of years. Ancient humans didn't just eat animals that still exist, they ate animals that we have rendered to fossils and paintings and museum reconstructions. They ate things that, if they existed today, would be in every nature documentary ever made. They ate the world's most spectacular wildlife, and then the wildlife was gone, and they moved on to whatever was left. Here is what was on that ancient menu. The woolly mammoth is the obvious starting point because it is the most famous, the most iconic, and the one with the most direct and overwhelming evidence of human predation in the archaeological record. Mammuthus primigenius, the woolly mammoth, was not the largest proboscidean to ever exist, but it was among the most widely distributed and the most thoroughly documented in its relationship to ancient humans. At its peak, the woolly mammoth ranged across a vast geographic swath of the northern hemisphere, from Spain through Siberia, across the Bering Land Bridge into North America, down through much of the North American continent. It was a social animal, almost certainly living in matriarchal family groups analogous to modern elephants. Adults stood roughly 3.5 meters at the shoulder and weighed between 4 and 6 tons. Their tusks, which could exceed 4 meters in length in older adults, were used for scraping snow to access vegetation underneath, for social display, and for defense. They were, by any metric, extraordinary animals. They were also, as the archaeological record makes unmistakably clear, hunted and eaten by ancient humans across their entire range. Mammoth kill sites are among the most commonly recovered large-game archaeological sites in Europe, Siberia, and North America. The site of Predmosty in the Czech Republic contained the remains of over 100 woolly mammoths in a deposit associated with human occupation and tool use, not naturally accumulated, not a mass drowning event, but the accumulated result of human hunting activity across a period of occupation. Cut marks on mammoth bones, the diagnostic signature of stone tool processing, are present at sites across multiple continents, on multiple skeletal elements, in patterns consistent with systematic butchering for meat and marrow extraction. Mammoth bones were also used as structural elements in shelter construction in parts of the Eurasian steppe where timber was scarce. They were used as raw material for tools and art objects. The mammoth was not merely prey, it was a comprehensive resource used across multiple categories of human material need. The evidence that human hunting contributed significantly to mammoth extinction is strong, though the full picture involves climatic change operating simultaneously. The end of the last glacial period brought warming that fragmented and reduced the mammoth steppe, the specific cold, dry grassland ecosystem that woolly mammoths depended on for forage. Warming and human pressure operated together, and the combination proved lethal in ways that either factor alone might not have been. The last woolly mammoths survived on Wrangel Island, an isolated Arctic island off the Siberian coast, until approximately 4,000 years ago, 1,000 years after the Egyptian pyramids were built. Their isolation protected them from human hunters. When humans eventually reached Wrangel Island, the mammoths vanished within a geologically short interval. The pattern of island arrival followed by rapid megafaunal extinction repeats across the global record with enough consistency to constitute a case study in what happens when large naive animals meet human hunters for the first time. The woolly rhinoceros, Colodonta antiquitatis, was the mammoth's ecosystem companion across much of Eurasia, sharing the mammoth steppe and appearing in the same fossil assemblages, the same cave paintings, and the same archaeological kill sites. It was substantially smaller than the mammoth, weighing somewhere between 1.5 and 3 tons, but its 2 horns, the longer front horn reaching up to 1.5 meters, made it a visually imposing animal whose soft tissues, unfortunately for it, preserved well enough that multiple near-complete specimens have been recovered from permafrost in Siberia and Ukraine. A frozen woolly rhinoceros recovered in Siberia retained stomach contents showing its last meal was grasses and flowering plants characteristic of the mammoth steppe ecosystem. The reconstruction possible from such specimens is extraordinary. We know what the last meals of individuals of an extinct species looked like because the permafrost preserved not just the bones, but the entire organism. Cave paintings from multiple European sites depict woolly rhinoceroses with an accuracy of anatomical detail. The 2 horns, the positioning of the first horn at the nose, the characteristic hunched profile. That confirms the artists were painting from direct observation rather than inherited description. The people painting these animals had seen these animals. Many of them had eaten these animals. The art and the butchered bones come from the same people, in the same cultural tradition. The steppe bison, Bison priscus, was the largest bovid of the Pleistocene Eurasian steppe, larger than either of its modern relatives, the European wisent and the American bison, with a horn spread that could exceed 1 meter from tip to tip. Like the mammoth and woolly rhinoceros, it is depicted in European cave art with technical precision that speaks to direct familiarity. The famous Lascaux caves in France contain one of the most celebrated examples, a large bison rendered in ochre and black with anatomical accuracy that has impressed artists and zoologists equally for the 8 decades since the cave was discovered. Steppe bison remains are found at European Paleolithic sites with butchery marks indicating systematic processing for meat, marrow, and hide. At certain sites, steppe bison bones are the dominant large mammal in the faunal assemblage, suggesting that specific communities may have been seasonally specialized bison hunters in ways that parallel the specialized bison hunting economies documented for later periods in North America. The steppe bison survived longer than the woolly mammoth, with some populations persisting into the early Holocene. Hybridization with the European wisent, whose descendants survive today, means that the steppe bison's genetic legacy is not entirely lost. Modern European bison carry ancestral DNA from the Pleistocene giant. But the full-sized steppe bison itself, the animal the cave painters knew, is gone. Cross the land bridge into North America, and the extinct menu expands dramatically. The Americas experienced what paleoecologists call the Pleistocene megafaunal extinction, one of the most severe and most rapid episodes of large animal extinction in the geological record, concentrated in a period between roughly 14,000 and 10,000 years ago that coincides precisely with the arrival and spread of the first human populations across the continent. The ground sloths of the Americas deserve specific attention because they represent one of the stranger items on the ancient human menu from a modern perspective. Animals so different from their living relatives that encountering them in life would require significant mental adjustment. Megatherium americanum, the giant ground sloth, was approximately the size of an elephant. Adults reached 6 meters in length and weighed up to 4 tons. Making them the largest ground sloths and among the largest land mammals of any kind during the Pleistocene. Unlike their small, arboreal modern relatives, giant ground sloths were terrestrial animals capable of rearing up on their hind legs to browse vegetation at heights no other ground-dwelling herbivore could reach. Their claws were enormous, curved, robust structures that limited direct ground contact and gave them a distinctive gait on the outer edges of their feet. They were, by all evidence, slow animals. Metabolically, anatomically, and behaviorally slow. This was not a prey animal evolved to survive determined human hunters with projectile weapons and cooperative pursuit strategies. Ground sloth populations had no ancestral experience with the specific hunting methods that humans brought to the Americas when they arrived, and the evidence suggests they were hunted extensively. Cut marks on giant ground sloth bones have been identified at multiple South American archaeological sites. At Cueva del Milodon in Chile, preserved dung, hair, and skin of Mylodon, a smaller but still substantial ground sloth, have been found in deposits associated with human occupation. The preservation quality is extraordinary and deeply eerie. The skin retains its structure, the hair retains its color, and the dung preserves plant material that tells us what these animals were eating. Everything we could want to know about a living animal, preserved in a cave, in a deposit that also contains evidence of the humans who were eating it. By the way, if you want to go even deeper into the secret lives of ancient humans, I just launched a full course called The Secret Lives of Ancient Humans. 10 modules, 3+ hours of content covering everything we never talk about on YouTube. What they feared, how they communicated, what hunted them, and much more. Plus an exclusive PDF guide included. Link in the description. See you inside. The American mastodon, Mammoth americanum, was not a mammoth despite the superficial similarity and the confusingly similar name. Mastodons were a distinct proboscidean lineage with different teeth adapted for browsing forest vegetation rather than grazing open grassland, different body proportions, and a geographic range focused on the forested and wetland environments of North America. They had been in the Americas for millions of years before humans arrived. The evidence for human predation on mastodons is comprehensive. The Manis mastodon site in Washington state preserved a mastodon rib with a bone projectile point embedded in it. Direct, unambiguous physical evidence of a human hunting attempt, dated to approximately 13,800 years ago. Multiple other sites across North America provide butchery-marked mastodon remains in clear association with human artifacts. Mastodons appear to have been targeted by early North American peoples as a significant prey species. Their forest habitat, which overlapped heavily with early human settlement patterns in the eastern half of the continent, put them in direct and sustained contact with human hunters. Their extinction was rapid by geological standards, from widespread and abundant to absent across most of North America within a few thousand years of human arrival. The American horse, Equus species, is one of the more thought-provoking entries on this list because it highlights how thoroughly human activities reshaped the world. Horses evolved in North America. The entire equid lineage, every species of horse, donkey, and zebra, originated on the North American continent and spread from there into Eurasia and Africa across the Bering Land Bridge. North American horses were present and diverse at the time of human arrival, and they were eaten by the first Americans. And then, they were gone. All North American Equus species went extinct during the same interval as the other megafaunal losses. Horses disappeared from the continent of their evolutionary origin before the Holocene was well underway. The horses that Columbus brought to the Americas in 1492, and that were subsequently feral adopted by various indigenous peoples as the Mustangs of North America, were returning to a continent from which their lineage had been absent for approximately 10,000 years. The ecological, cultural, and historical consequences of that return, the horse cultures of the Plains peoples, the transformation of North American indigenous societies through horse adoption, all of this happened because the original North American horses had been hunted out millennia before. The short-faced bear, Arctodus simus, was one of the largest terrestrial mammalian predators in the history of North America, and its presence on this list requires explanation because it was certainly capable of reversing the hunter-prey relationship under the right circumstances. Adult males may have weighed over 1,000 kilograms, with long limbs that suggest a faster, more pursuit-oriented locomotion style than modern bears. Its short face housed powerful jaws capable of cracking bone. Whether Arctodus was primarily a predator or a hypercarnivore scavenger, capable of displacing other predators from kills is debated. What is less debated is that early human populations in North America and Arctodus overlapped geographically and temporally, and that Arctodus went extinct during the same interval of rapid megafaunal loss that eliminated most of North America's large mammals. Whether humans hunted Arctodus directly, or whether its extinction was a secondary effect of the prey-based collapse, the loss of the large herbivores whose carcasses may have supported it, the human contribution to its disappearance appears in the overall pattern. The idea of early Paleo-Indian hunters encountering a 1,000-kilogram short-faced bear and making decisions about that encounter is one of the more dramatic scenarios the ancient human experience offers. There is no direct archaeological evidence of short-faced bear butchery, but there is also no surviving short-faced bear. Australia's record of human-caused megafaunal extinction is among the most thoroughly documented and most sobering in the global picture. When modern humans arrived in Australia approximately 65,000 years ago, they encountered a continent that had been evolving in isolation for tens of millions of years, producing megafauna that existed nowhere else on Earth and that had no experience with human hunters. Diprotodon optatum was the largest marsupial to ever exist, a wombat relative roughly the size of a rhinoceros, weighing up to 2.5 tons. It was the largest member of a diverse Australian megafauna that included giant kangaroos, large flightless birds, and a range of predators and herbivores that dwarfed their modern Australian counterparts. The extinction of the Australian megafauna was once attributed primarily to climate change, but the accumulated evidence has increasingly pointed toward human arrival as the primary driver. The timing of extinction aligns closely with dates for human colonization in various parts of Australia, and the pattern of which species went extinct, heavily weighted toward large, slow-reproducing animals, matches the expected signature of hunting pressure rather than climate-driven habitat change. Direct evidence of human predation on Diprotodon and related Australian megafauna has been difficult to establish at specific sites, partly because the time depth involved means that organic materials are rarely preserved with butchery marks recoverable in Australia's climate. But the demographic pattern, large animals disappearing shortly after human arrival, followed by the survival of smaller species, aligns consistently with a hunting-driven extinction model. What ancient Australians ate in the millennia following their arrival on the continent represented in aggregate the liquidation of tens of millions of years of isolated evolutionary history. The megafauna that survived, the kangaroos, the wombats, the emus, are the ones that proved somewhat compatible with human hunting pressure. The ones that didn't survive were simply gone. The elephant bird of Madagascar, Apiornis maximus, holds the distinction of being the heaviest bird to have ever existed, estimated at up to 500 kilograms. It was flightless, obviously, and laid eggs that were the largest of any animal since the dinosaurs. Individual eggs with a volume equivalent to over 150 chicken eggs, or roughly 7 ostrich eggs. Humans arrived in Madagascar approximately 2,000 years ago, making Madagascar one of the last major landmasses to be colonized. And the elephant bird's extinction followed within a relatively short interval. Ancient DNA analysis has confirmed that elephant birds were hunted by early Malagasy peoples, and archaeological sites on Madagascar contain elephant bird eggshell fragments in quantities consistent with systematic use of both the eggs and the adult birds as food resources. The eggs alone would have been a significant caloric resource. One elephant bird egg contained approximately the caloric equivalent of 150 chicken eggs, representing a food windfall that required no hunting skill to acquire, simply locating a nest. The combination of nest raiding for eggs and hunting of adults applied to a slow-reproducing island-evolved species with no fear response calibrated to human hunters produced predictable results in a predictable time frame. The dodo, Raphis cucullatus of Mauritius, is probably the most famous extinction in human memory, primarily because it happened recently enough to be documented in contemporary European accounts, drawings, and biological specimens, and because the speed and totality of the extinction struck even people at the time as remarkable. The dodo was a large flightless bird related to pigeons that evolved on Mauritius in the Indian Ocean in the absence of any mammalian predators. Its flightlessness and its lack of fear response to humans were not stupidity. They were the absence of selection pressure against those traits, which had never been relevant in a predator-free island environment. When Dutch sailors arrived on Mauritius in 1598, they found dodos that could be approached and killed with minimal effort. Multiple contemporary accounts describe exactly this and describe the birds being eaten aboard ships during the long voyage home. The dodo was extinct by approximately 1681, within roughly 80 years of European contact. The direct contribution of hunting was compounded by the introduction of pigs, rats, cats, and other animals that preyed on dodo eggs and competed for resources. But the initial vulnerability, the complete absence of fear response to human hunters, was the product of its island evolution, and it was fatal. Steller's sea cow, Hydrodamalis gigas, was a massive sirenian, related to modern manatees and dugongs that could reach 8 to 9 meters in length and weigh between 5 and 10 tons. It was discovered by Georg Wilhelm Steller during Vitus Bering's 1741 expedition to the Commander Islands in the Bering Sea, at which point the surviving population was already restricted to a small area around these islands. Within 27 years of its discovery by Europeans, it was extinct. The mechanism was the same as elsewhere. An animal with no experience of human hunters, encountered by hunters who understood its value as a food resource for long ocean voyages, harvested unsustainably until none remained. Steller's sea cow could not escape by diving deep. It was too large to submerge fully and spent most of its time at the surface feeding on kelp. It was reportedly docile, made no attempt to flee from hunters, and died in visible distress that other individuals attempted to interrupt. Behaviors that in a different world might be described as socially admirable, and in this world were simply lethal vulnerabilities. The pattern across all of these species, the mammoths, the ground sloths, the mastodons, the Australian megafauna, the elephant birds, the dodo, Steller's sea cow, is not a pattern of ancient people being uniquely destructive or unusually cruel. It is the pattern of a highly effective predator encountering prey that had not co-evolved with it and therefore lacked the behavioral calibration to respond appropriately to the threat. The megafauna of Africa, the elephants, the rhinos, the hippos, the giraffes, survived in much greater proportion than the megafauna of other continents. The most widely accepted explanation is that African megafauna co-evolved with the human lineage over millions of years, developing fear responses, flight distances, and behavioral wariness calibrated to human hunters during the period when human hunting capabilities were developing gradually. By the time modern humans were capable of hunting large prey effectively, African animals had already been selected for caution around humans. The megafauna of the Americas, Australia, and isolated islands encountered modern human hunters for the first time in their evolutionary history, the full hunting capability arriving without the long period of escalating pressure that would have allowed prey populations to adapt. The result was naivety in the face of systematic predation, and the result of that was extinction at scales that, looking backward from the present, constitute one of the most significant ecological transformations of the last 100,000 years. The campfire in southwestern France is still burning. The people around it are still eating. And somewhere in the darkness beyond the firelight, the last mammoth in that region is alive, grazing on cold season grasses, unaware that it is among the last of something that will never exist again. The people around the fire don't know that either. They are hungry and cold, and the mammoth is food, and that is the full extent of the calculus available to them in that moment. Understanding this doesn't excuse the outcome. The outcome is still the permanent loss of animals that had survived 30,000 years of ice ages and would have been alive today in their absence. But understanding it is the only way to actually learn what the extinction record has to teach. which is something about what happens when a particular kind of intelligence meets a world that hasn't had time to adjust to it. We are still that intelligence. The world is still adjusting. Some things never change, and some things change everything, and sometimes those are the same thing wearing different centuries.